Okay, let's look at one of our homework questions with our elevator questions. Elevator. So I have a man measures the acceleration of an elevator by using a spring balance. He fastens the scale to the roof and suspends a mass from it. The scale is going to read 98 newtons when the elevator is at rest, and it's going to read 93 newtons when the elevator is moving. So I want to know in which direction the elevator is accelerating, and I know it must be accelerating because the readings are different. And I want to know what is the acceleration. So I need direction, and then I need a value. Okay, so let's see what's happening here. Let's draw my elevator. And I have a scale, and from my scale is hanging my mass. So when it's at rest, then I know at rest means the sum of my forces is 0. So in here, I need a free body diagram. Where am I going to stick it? I'll stick it here. I know I have a force up, let's call it tension, and I know I have a force of gravity down. So then that means, let's see here, I'm just going to move that over. That means the sum of my forces in the y direction is going to be equal to 0. So that means tension and force of gravity, those vectors have to add to 0. I'm going to call up, I'm going to make my little reference here, I'm going to call up as positive and I'm going to say down as negative. So that means my tension is up, it's going to be plus. Force of gravity is down, so it's going to be minus. It all totals to 0. So that means that my tension has to equal my force of gravity. And I'm being told that my tension is 98 newtons here. Oops, that looks pretty bad. So that means, therefore, my force of gravity is equal to 98 newtons. Okay. It didn't ask me that, but, you know, that's what I know. Now I'm moving. And I know I have to be accelerating because my scales are different. So that means that the sum of my forces is no longer equal to 0. It's not going to be equal to mass times acceleration. So I still have my tension up. Right? My free body diagram doesn't really change. One arrow is now going to be bigger. Times mass times acceleration. My tension is still going to be up. My gravity is still going to be down. And that's all going to equal mass times acceleration. I don't know my direction of the acceleration yet. I got to do some calculations first. Tension, we're told, is now 93. Force of gravity, we figured out, was that 98. So I'm going to sub that in over here. Equals mass times acceleration. 93 minus 98 gives me a minus 5. So I can say, therefore, the net force is down. Because it said negative. Negative is down. The net force is down. Therefore, acceleration is down. So that could mean I'm speeding up when I go down. So maybe I'm just starting down. Okay. It could also mean that I'm slowing down while I go up. So we got two different directions it could be going. The acceleration itself is down. What is the acceleration of the elevator? So now I got to use my numbers and I got to do some figuring out here. What is the acceleration? So if I'm looking for acceleration, well, we definitely want to keep working with this. But I don't have a mass. Oh dear. I'm going to have to find that. Where am I going to find that from? Well, if I look back here, let's see, force of gravity. Well, that is mass times gravity, right? Mass, we don't know, but I know my g is that constant of 9.8. So if I divide both sides by 9.8, can I get my mass? Yes, I can. So now that I have that, now I can finish. So I'm going to bring that down here. So for B, I want to figure out my acceleration. So I've got my negative 5 is my net force equals mass times acceleration. And then I just figured out that mass is 10. Divide both sides by 10. And what's that? Negative 5 divided by 10 gives me a negative 0.5 equals acceleration. Therefore, the acceleration is 0.5 meters per second squared. And I defined the negative as down, so therefore it's down. Let's do another one. So now we've got a fish is hanging from a spring scale supported from the roof of an elevator. Hey, it's almost the same idea. If the elevator has an upward acceleration of 1.2 meters per second squared, and the scale is reading this while it is accelerating, so that's while accelerating, we want to know the true force of gravity on the fish. We want to know when the scale would read 150 newtons. So under what circumstances? What's the elevator doing? Is it speeding up, slowing down, going up, going down? I don't know. And what would the acceleration be? And then what would the scale read if the elevator cable breaks? Oh no. Okay, one step at a time. What is the true force of gravity on the fish? I don't know. Let's think about what we know. There's my elevator. We said the spring scale is from the roof, so there's the scale. And then, forgive me, I am not an artist. There's my fish. So my free body diagram would be the force of the tension, that's what the scale is reading, and the force of gravity going down. We have the sum of our forces in the y direction is going to give me mass times acceleration in the y direction, right? We're just going up and down here. We know that we have a tension going up, and we've got a force of gravity that's also acting as well, so we've got those two vectors. Tension, I'm going to keep my up as my plus. You don't have to, but I am. And gravity is down as my minus. So I know, even without really using any numbers, I know I can set this up because that's what my free body diagram says. So let's go back and see if we can't find some numbers. So our scale is reading 200 newtons. So there's my tension. Here's my acceleration. Okay, so let's stick those in. So I have a tension of 200. And I have an acceleration of 1.2. Do I know any other numbers here? Fish hangs from the scale, has enough percent. What is the true force of gravity? Oh boy. No, I don't. Do I have a mass? No, I don't. Oh boy. Well, now what do we do? Well, if we think about it, I know that the force of gravity is defined as mg, right? That's its definition. And we know that, right? We talked about the big force of gravity and all the rest of it. Okay, so let's stick that in there. Minus mg equals m times 1.2. Okay. Oh, we still don't know mass. Oh, but I know what g is, right? We know g is defined as that 9.8. So m times 9.8 equals m times 1.2. So I've subbed in my definition, right? And then I subbed in the fact that g equals 9.8. Right? 9.8 meters per second squared. That's what we've been using. Well, now I only have one variable left. Oh, so let's, like, you know, rearrange, collect like terms. So let's see, that's 200 is going to stay. I'm going to bring this to the other side. So that's going to equal to 1.2 m plus 9.8 m. So 200 is going to equal, what's that, 10, 11? 11m? Divide both sides by 11. I don't know, what do you get? I get 18.18. So my mass is going to be equal to 18.18 kilograms. So that's helpful. That's helpful for sure. Now I know my mass. So if I know my mass, let's then sub that in. We're going to sub that back in. Sorry, I'm bouncing around here. Into this whole FG business. So now we're going to say my FG is equal to mg because I want to know the true force of gravity. I just figured out that I have a mass of 18.18. And I know g is 9.8. So let's calculate that. I don't know. What's it equal? So I get an answer of 178.18. We're in force of gravity here, so newtons. Therefore, the true weight is 178 newtons. Okay. So there's A. Under what circumstances will the scale read 150 newtons, and what would be the acceleration of the elevator? Okay, so I want the scale. Do I have enough space? Let's see if I can fit it up here. I want the scale to read 200 newtons. No, not 200. What did I say? 150. 150. Sorry. So this is B. So this is when my tension has to equal 150 newtons. And I want to know what the acceleration is going to be. Okay, well, same free body diagram, same setup. Sum of my forces in the y direction is mass times acceleration. So force of tension is going to go up. And gravity is going to go down. So we're going to add up those vectors. So plus tension. So the tension is going to be my 150. Minus gravity is down. And we just figured out gravity. That's my 178.18 equals mass. What's my mass? 18.18 times my acceleration. Oh, look at that. I know everything. So let's see. 150 minus 178.18 gives me a negative net force of 28.18 equals 18.18 acceleration. Divide both sides by 18.18. Divide by 18.18. Therefore, acceleration is going to be a negative. Divided by 18.18 is 1.55. Negative 1.55 meters per second squared. So that's telling me, therefore, the elevator is accelerating down at a rate of 1.55 meters per second squared. So make sure you've got that down somewhere, either in the sentence or afterwards. Now the question says under what circumstances. So that I know the acceleration is going to go down. So just be careful with that one, right? So that either means, so I know my acceleration is going down. So I either start from rest. So either start moving down. Or I could be stopping while the velocity, while the elevator is going up. Right? So if the velocity is up and the acceleration is down, right? You're slowing down. And then last but not least, what will the scale read if the elevator cable breaks? So if it breaks, that means there is no tension. Therefore, the scale is going to read 0. Because there's no tension, so you can't read what's not there. Good times.